Light, although unfortunately it's going to be in some folks' eyes, and haven't been able to figure out how to pull the curtains across, but it's sunny nonetheless. So welcome. So what I'm going to talk about today is just basically statistics collection in LUW, and there's a lot of DB2 LUW's stats collection is a pretty rich functionality now. It's been extended over various releases, and there's quite a number of things that you can do to provide the optimizer with better information. But what I'm going to try to go through is just some simple best practices to make that easier for you to do, and then give you some tips on how to collect some more advanced statistics if you want to do some additional tuning. So these are the objectives as they were in the abstract submission, and for some reason it, oh, there it goes, okay. And this is the overall agenda. So we're going to do a quick review of RUNSTATS, talk about automatic stats collection. So basically, I always recommend let DB2 collect the stats for you. We'll go through the details on that. And there's some best practices about how to decide, tell DB2 what stats you want to collect and when. And then we'll go through a variety of other options that DB2 RUNSTATS supports, from sampling to some extended syntax and some more detailed stats like column group stats and index stats and a variety of other things. So I won't run through the whole agenda right here. So let's get into the RUNSTATS review. So basically, RUNSTATS is a utility within DB2 LUW to collect statistics about the data in your tables and the physical characteristics of those tables. And so there's basically two categories of stats that are collected. There's the physical stats, so it gives you some information about how big the table is, how many pages, how many rows, the number of levels in an index, number of leaf pages, so the physical characteristics. And then there's also stats about the data characteristics. So how many, what's the number of frequent values, or the distribution of data in a column, the number of distinct values in a column, so everything kind of related to the data. And these statistics are stored in the DB2 LUW system catalogs, and you can see them through a set of catalog views, either the sysstat or syscat views. And there's actually just really 5 views that contain all those stats. And the stats, so why do we have RUNSTATS in a stats collection utility? It's primarily for the optimizer. So the optimizer is deeply confused without statistics. And there's been some other sessions here this week going through how the optimizer uses the stats. Joe had one yesterday on filter factors, so lots of good detail on how these are kind of consumed and the computations the optimizer does. I'm going to focus more about how you collect them, and a little bit of information on how it's used in a couple of simpler examples. So basic recommendation is should always be collecting catalog statistics, and you can do that either manually with the RUNSTATS command, or you can use automatic or real-time statistics collection. If you choose to use the RUNSTATS command, these are the options on this page that I recommend. Whoa! Yeah. That was the ghost. That's. Were they coming or going though? I don't know.
Maybe you shouldn't use detailed index.
Yeah, exactly. Yeah. Got a second opinion on that one there. Okay. Okay. So these are the default stats options I recommend, and I'll tell you why on the next slide. And then I recommend collecting stats. Let DB2 collect stats for you automatically, and then if you want to do some additional tuning, recognize that you have certain characteristics in your queries and data that you might need some additional stats. There's some other things you can collect, like column group stats, stat views, and stuff that's a little bit even more esoteric, like statistics to help like predicates. So there's lots of different stats that DB2 supports. So why do I recommend distribution stats? Just by default, because first of all, it's easier just to put the with distribution clause on the statement. It doesn't really add that much overhead, and most of the time there's skew in the columns, so it's good to have distribution stats. And so we have two different types of distribution stats. One that represents the top most frequent values in a column. So in these, in this example, we've got the state code. And for whatever reason, California is far more frequent than, say, New York or Texas. The optimizer uses that. If you have a search condition that's looking for a particular value, it will know, exactly, how many rows exist with that particular value, and that can make a big difference in terms of whether the access plan should be an index scan, a table scan, affects join orders. And the other distribution stat that LEW has is quantile or histogram statistic, and so this will, the way it's recorded in LUW is that basically each entry, the count, the val count, represents the number of values that are less than or equal that value in that column, and so these histograms are used for between or range predicates, and so classic example here, for looking for dates in a particular range. And you can tell RUNSTATS how many frequent values or quantiles to collect. You can do that on the RUNSTATS command. There's a database configuration parameter that you can set at the database level. So a couple different ways to do that. So automatic stats collection. Next tip. So what is automatic stats collection in Db2? There's actually sort of two forms of this automatic stats. There was the original one that was introduced in version 8.2. I'll talk more about what the differences are. And then this additional form of automatic collection called real-time stats was added in 9.5. And so the basic idea for both of them, they have the background component where the stats are collected by a daemon that wakes up at various intervals, determines what stats need to be collected, and collects them. The real-time stats is actually collects the stats when the statement's prepared. So when you actually do the prepare, it will go and drive a RUNSTATS at that point in time. Not every time, but depending on the needs of the query and whether or not the stats are stale or not. Now it doesn't always. Sorry, question here. Yeah, so the point here is that the prepare could take longer, and I'll talk a bit more about how long that can be. Actually, it says right here on the slide. Sorry, yeah. So the maximum amount of time that RUNSTATS will take during prepare is 5 seconds, and on the next page I'll show you how, or a couple pages, show you how to configure that. But and you can reduce that if you find if 5 seconds is.
But this depends on when the last real RUNSTAT has been run, how many rows have been changed. Yes.
That's right. So comment here is that this real-time stats isn't going to occur on every prepare. It's only going to occur if the analysis of the stats and the query determines that it really needs to collect stats. So there's this whole analysis that goes on based on the amount of update and delete and insert activity that's occurred on the table, and once it crosses a certain threshold, then it'll decide that it needs to drive that stats collection. So it's yeah, that's right. Sure, it's all in this slide. So amount of change over time, whether or not there's a change, just because there's been a lot of update activity against that data, it doesn't necessarily mean that the distributions have changed. So it's another thing. It'll actually compare the data distributions over time, and if it doesn't think it's changed, it won't drive a RUNSTATS. And the important thing is that the either the background or the real-time stats are designed to be unobtrusive and have low overhead. So for example, when the stats are written to the catalog, if there's any other application that's accessing the catalog and needs to get those locks, the auto run stats will get forced off. It will never hold up any other application, and it won't take any locks on the table either that would block any other application. And it also uses the built-in utility throttling that LUW has. So for most utilities, you can specify, I think it's util, I forget the exact syntax. That just happens automatically for the auto run stats as well. So so I think I've pretty covered this in a little bit more detail. So the original auto run stats was added in 8.2. The way it worked is that periodically this background process would wake up, check the tables, see which ones need stats, and then it would drive a stats collection. And this would happen about every 2 hours. The real-time stats, as I mentioned, the stats collection happens at prepare, statement compilation time. We talked about, it's based on, it actually looks at the predicates and uses of the columns in the query and determines, does that query need distribution stats? Maybe it doesn't. For certain very simple statements, like in an OLTP system, if it's doing like a primary key lookup, the optimizer can make that decision without stats, so it wouldn't drive a real-time stats in that case. Now the key thing with the real-time stats, when it does collect the statistics, it doesn't actually write them to the catalog at that point during prepare. That would not be good for with the additional overhead and locking that would occur at prepare time, and we wouldn't be able to do that with one of these special low priority locks because it's happening within the user's connection that's actually doing the prepare. So what happens is that these stats are stored in memory in a special statistics cache, and then later on a background process will wake up and write those stats to the catalog. So these stats are published immediately in the stats cache, and they become available to any other prepares that occur, right after they go into the cache. So I covered everything on here. So how do you enable automatic stats, real-time stats? So this is the way the database configuration parameters look as of 11.1. So there's a hierarchy of switches. Top one for the stats is auto run stats. I don't know why this thing keeps kicking in here. And then below that, there's the different options for the different flavors of auto run stats. So you've got the real-time stats. So the switch is auto statement stats. You can also collect stats on statistical views automatically. And then there was a new option added in 10.1 so that the auto run stats would automatically determine the sampling rate for both real-time stats and the background stats. And I highlight on this page that auto sampling is enabled by default for any new databases created on version 11. And then just kind of walking backward in time for what the configuration parameters looked like back in 10.1, where the last time they were changed. In 10.1, the statistical view switch was added, and the auto sampling switch was added. But at that point in time, they were both off by default for 10.1. And going all the way back to 9.7, a couple of other notable changes. One, actually back in 9.7, the switch for real-time stats was called auto statement stats, and found that confusing. So you'll notice that like in 10.1, it was changed to real-time stats. And then there were two other configuration parameters that had existed in version 8 all the way up to 9.7. It's auto stats profiling and this automatic profile update. Those were actually removed in 10.5. And those enabled a type of stats recommendation that would determine some of the stats I'm going to talk about later on in the presentation were automatically recommended by Db2 at that time, but there were some limitations with that capability. It didn't work in an MPP environment. It didn't work if you had intra-partition parallelism enabled, and it didn't occur in a timely enough fashion, so we decided to remove that capability from the engine, and those stats recommendations are now all part of the stats recommendations that are provided by the stats advisor in Data Server Manager. So that's the config params walking back in time. So next we'll talk about some best practices for collecting stats. So basically, I recommend using automatic stats collection, including real-time stats. So have those two switches on. It'll collect stats at the right time, and it will avoid like over collecting stats, because sometimes if you really don't know when or what stats to collect, you might just tend to be doing run stats on regular intervals, and there could be a whole set of tables where the data is really not changing. You don't need to, you don't need to do the run stats. It's just easy to do it this way. I've already mentioned that it's throttled. It's actually, when the system's busy, it won't have any more than 7% overhead using the throttling. We talked about the 5-second limit. Doesn't take any locks. So use auto run stats, real-time stats, and then if there are certain tables where you would like to have more control over when the stats are collected, you can handle those exceptionally, so you can exclude those, and I'll talk about how to do that. And then finally, just mention that there are certain utilities that you will collect statistics when you run them, and I recommend using those options because it's just saves some extra time having to do a second pass to collect the stats after you've run that utility, and I'll talk about that later on in the presentation. So we had a question about, so the real-time stats taking 5 seconds during prepare time. You can control that with an optimization profile. So you can just an element called RTS time. It's in milliseconds. You can also disable real-time stats altogether for certain statements. Again, you can just put this as a comment on the SQL statement now in version 11, and you can control it at that level if you want. You can't override the database configuration parameter with this option. So, for example, if you have auto statement stats disabled, you can't just enable it with the RTS option. Enable that has to. It's kind of a hierarchy, so that one has to be on. And with the optimization guidelines, there's a couple of different ways to do it. You can do it. You can put this configuration option on the statement as a comment. You can also put it in an XML document that gets stored in a table. That's the second way to use hints or optimization guidelines in LEW, and within that you can do stuff where you can even control real-time stats at the session level, right? So it doesn't have to be associated with a particular statement. So there's some flexibility with how you can specify the RTS time limit. And then so I talk about handling exceptions. So typically I've seen auto run stats works great for a large number of tables. There might be some maybe very large tables or tables where the queries and access plans are sensitive to the changes in stats. So maybe you want to say, well, I want some predictability, so you can exclude these tables from auto run stats, and there's a way to do that with something called automated maintenance policy. I'll show that on the next page. So there's two things you can do. You can schedule when auto run stats occurs, so you can set a maintenance window with this policy, and you can also specify exactly what tables are not to be included with auto run stats, and then those ones you would just collect stats manually. And you can also, and for the very large tables, another way to handle them is that if you just use the auto sampling, sometimes that if you're concerned about the length of time that the run stats is going to take, even for the background stats, because it could take quite a long. It's going to take just as long for the background, perhaps even longer, because it's throttled if you do a full unsampled run stats. So I highly recommend having the auto sampling option on. However, on run stats, you can specify the sampling rate yourself and record that in the catalogs, and I'm going to talk about how you can do that a little bit later on in the presentation. So that's how you handle very large tables, sensitive tables. There's another category of tables I call volatile tables. These are ones where the contents of the table changes frequently, so that the table might be empty, then it gets populated, some queries run, and then the contents are deleted and repopulated, and it's almost like a queue table where put some kind of work in there, stuff gets picked out of the queue and then deleted. Various different flavors of tables that can have these characteristics. The issue with them, though, is that because the stats are changing, the data is changing so frequently, it's hard for the real-time stats and auto stats to kind of to keep up with it and have a consistent view of the stats. So one way to do that is you can just exclude those, manage those on your own. A couple of different ways to do that. One is there's an option on alter table to mark a table as volatile, and that's been used over the years. That's not my first choice. The approach I prefer would be to actually set some representative stats for these types of tables, and then just never change those stats again. And if you find a set of stats that kind of works for most queries and is kind of representative of that data, that's usually a good option for these types of tables. And there's a couple different ways to do that. You can just populate the table with a representative set of stats, do a RUNSTATS, and then never do a RUNSTATS on them again. Another way to do it is then LDW would actually have the ability to manually set the stats in the catalog with update statements. And as soon as you do that, for any table, that automatically excludes the table from auto RUNSTATS. As soon as you do that update, we kind of recognize, okay, you've taken control of the stats, and auto RUNSTATS won't occur for it either. So it's one way to handle volatile tables. Just quickly on automated maintenance policy, I won't actually go through this in detail, just only to say that there's a couple of store procedures that you use to set this policy. The speaker notes have some examples of what that looks like, and there's some pointers to the documentation. The maintenance window itself doesn't apply to the collection that happens at prepare time, because the idea with that is it's just supposed to always happen kind of in real time, so the maintenance window doesn't really apply to that. But the table list applies to both real-time stats, so the synchronous and asynchronous collection. And I mean, it's possible you could completely eliminate the maintenance window, so there's none at all, so that only the stats collection that occurs at prepare time would be happening. So I'm not recommending that's something you do, but it's kind of an interesting thing that you can do with this policy. But if you did that kind of thing, the stats would only ever be in memory, right? And so.
Just a comment, because if you enable this time maintenance activity, it will also influence on the real.
Yeah, so the comment here is that this maintenance window also affects the auto reorg as well. Yes. That's right. Yeah, I think there's no. Yeah, it's one maintenance window that affects all the autonomic operations. So yeah, good point on that one. And then quick comment on static SQL. So we talked about we have auto run stats. So obviously dynamic SQL will immediately pick up the new stats when it's prepared, because the stats are in the stats cache and in the catalogs. Static SQL will not be automatically rebound after run stats. So if you want the access plans within the static SQL to reflect the new stats, you'd have to do a rebind. And so you get the question as well as should you always do a rebind after you do run stats? And this is one of those it depends answers. So if your SQL really is sensitive to the data and the access paths can be quite bad if they're not recompiled, then yeah, you do want to do a rebind. But there's some applications where the access paths really aren't that sensitive, and if you don't want to, these applications really can't take the risk of some plan flipping and performance regressing. So in that case, if you can't tolerate the risk for those types of applications, then you probably don't want to do the rebind, right? So kind of your choice. But the point here is that Db2 will not automatically do the rebind because of the run stats. So we leave that in your hands. All right, moving on. The next section, sampling options. So quickly go through this. So on the RUNSTATS command, you can specify how to sample the data. So this is really good for large tables and indices, and we've got automatic sampling. I mentioned that it was introduced in 10.1. So you can sample the data pages, the index pages, and you can even do sampling when you collect stats on stat views. So I'll just jump through a couple of these slides. So basically what it looks like is there's just two options. You've got a kind of a fancy name, Bernoulli and system. Bernoulli basically just means row sampling. These terms are chosen because we actually have the ability to specify sampling when you run queries. So actually LEW's had this support for query sampling since, oh my goodness, could be even back to like version 2 or version 7. So So we used the same kind of concept for the RUNSTATS. So Bernoulli gives you row sampling, and system gives you page level sampling. And then you just specify the sampling percentage. And you can also, there's actually another kind of option that goes along with that called repeatable. And it's not used all that much. Why it's there is that if your table, if the data is not really changing and you're reissuing the sampled RUNSTATS, it just means that the seed for the random function that does the sampling will remain the same across those RUNSTATS, and so you'll get deterministic stats based on sampling. So it's not used that often. I haven't seen a lot of use for it, but it's there if you want to have a little bit more deterministic stats from sampling. The auto sampling rate added in 10.1. So this applies to tables, indices, and stat views. So the sampling rate is determined based on the size of the table. It's going to use page level sampling by default for both the data and index pages, and there is possible in some cases to do page level sampling for stat views as well. So, row page level sampling, which is recommended? So, advantages and disadvantages with either one. With row sampling, you're not going to see as much of a performance benefit from that because it has to do the full I/O on the table. So every data page is going to be read, or every index page. But you could still see a big improvement because of the saving in CPU. So it kind of depends on whether how fast the I/O is on your system. And it may provide more accurate stats because with the page level sampling, it's only going to read so many other pages based on the sampling rate. And so that will perform significantly faster because it's going to avoid the I/O. It's also using prefetching when it does the sampling. So it's actually using this new index read ahead prefetching for the index leaf pages that was introduced in version 10. So the I/O is quite efficient for both the data and index pages. There's a chance that the stats might not be quite as accurate as row because it's reading every other page. If the data tends to be clustered on the pages, it might end up missing certain values that only existed on a small number of pages. So the RUNSTATS does try to detect this data clustering effect and adjust for it, but there's a chance it might be a little bit off. I recommend going with the page sampling. I haven't seen cases where it's significantly more incorrect than the row sampling, or less accurate, and that's the default that we use for the auto sampling option as well. So I'd say go with page sampling. I've already kind of gone through this, and then I find a good starting point, even for very large tables, is like a 10% page level sample, and then depending on even for very, very large tables, you can even reduce it further from there. Sometimes a 1% sample, a 0.1% sample is actually good enough to provide accurate stats for like very, very large tables. And then just to comment, out of all the stats that are extrapolated from a sample, it's the number of distinct values in a column that's mathematically more challenging to extrapolate. So if anything, that's the stat that you'd want to take a look at to see what the accuracy is like based on the sampling rate. Okay, so that covers sampling options. I'm going to talk about some extra syntax options that RUNSTATS has. If you look at the syntax diagram, it's looks kind of big and complicated, but it's not too bad. The whole idea behind most of these options is to, well, for some of them, it's to just reduce the RUNSTATS time by eliminating certain columns. In other cases, the options are to collect some additional more sophisticated stats. So let's rather than go through these, I'll just kind of jump into some examples. So. For example, if you want, this first example, if for whatever reason you only really needed stats on 2 columns in the table, you would just use this on columns clause and just list those 2 columns. And in this case, it doesn't even collect distribution stats. It just gets the basic, high 2 key, low 2 key column cardinality on those 2. Or there's an on columns clause that you can put on the with distribution clause. So you can kind of again, just collect stats, but just on those two columns. Excuse me. You can get fancier and specify, I think I mentioned this earlier, the number of quantiles and frequent values that on a per column basis, or at the sorry, in this example, yeah, for these you can customize it for individual columns as is shown on this page. And another kind of option that kind of more of a convenience thing, although it's something you have to be a little bit careful with, is the on key columns clause. This basically just says only collect stats on columns that are keys in indices. And the rationale there being that those are typically the columns that are going to have filtering conditions. And that that's sometimes the case, but not always. So you want to use that one with a bit of caution. But you can combine that with the and columns clause. You can say pick up all the index key columns and maybe some additional columns. You can specify specific indices on which to collect stats. This option, you know, if you had just created a new index, a better way to do this is to collect the stats at the time you create the index. So I'm going to show in a couple of pages how to do that. But if for some reason you know, maybe there was a reorg done on that index and you want to update the stats, you can just do the run stats on that and just for the index, not even the data pages. And then there is a a special form of stat for varchar columns, or for varchar columns that help the optimizer get a better filtering estimate for like predicates. So like is like kind of like a pattern matching, and so if you find the filter factors are somewhat inaccurate for that, you can try this like statistic and put some additional stats in the catalog that I'm not going to go into detail in this presentation. So I mentioned the benefit of these particular options is to just generally improve the performance, because gathering stats is CPU intensive for some of these. Sometimes many of the columns aren't used in predicates, or order bys and group bys distinct. Those operations actually use the catalog statistic as well, but some columns don't, never appear in any of those types of operations. Many columns, excuse me, don't even require distribution stats. So there's different ways that you can customize it. However, rather than trying to do all that by hand, what I really recommend is using the statistics advisor that's part of Data Server Manager. And that's a far easier way to get a really good set of stats options for your tables. And the way this works is that you give it a workload, a set of SQL statements. It's good to give it a good representative sample, and it'll go through and it'll make all those decisions that I showed on the previous page. Do that for you. And and the stats advisor also existed in the older version of the tool, the Optim Query Tuner. All right. So next section I want to talk about are column group statistics. So I'm going to kind of dive into some kind of additional, more sophisticated stats you can collect on tables. So what do we do with what's a column group stat? So just to provide a bit of background for an example, very common within databases where set of columns, one or more, two or more, sorry, are related. They have some sort of correlation. So very typical. One example you typically see is like an automobile database, make and model. Something here a little bit more relatable to the business world. So like an insurance database, and you've got a policy table and a claims table, and you typically have a policy number, and each policy would have a number of revisions. And what might happen is that you might have one policy that's had like 20 revisions, and that's kind of like the maximum that exists. But most policies maybe only have one or two revisions, right? So the actual number of combinations of policy numbers and revisions isn't the product of the number of distinct values in each one, it's actually a smaller number, right? So, in this case, maybe there's only, rather than there being like 200,000 combinations, there's only 40,000, right? And so that type of information is important for the optimizer to know. So next page will show you kind of how it's used. So very common situation with the with correlation in columns is when the optimizer is trying to estimate the filtering. In this particular example, it's the filtering of a join between the policy table and the claim table. So you're going to join on the policy number and you're going to join on the policy revision. And without knowing the number of distinct values in that set of columns, the optimizer is just going to treat them independently. And the the computation, the way it's going to work, is that this is actually the formula for the way the optimizer computes the filter factor for joins. And it's really, it looks at both columns in the equijoin, and it's 1 over the maximum call card. And the rationale behind that is that's it assumes that the number of distinct values in the column with the actual values in the column with the smaller number of distinct values is a subset of the one in the larger one. So it's always kind of assuming a parent-child relationship in that case. So that's where that formula comes from. So in this case, the filter factor for the policy number join would be 1 over 10,000 because that was the number of distinct values and policy number in the policy table. And then similarly for the revision, it was 20, so it's going to be 1 over 20, and the filter factor would then end up being 1 over 200,000 in this case. But if the optimizer had that column group stat that said there's only 40,000, really the filter factor should have been 1 over 40,000, and so it had underestimated the cardinality of the join by a factor of 5. So like the filter factor was that much smaller, so the estimate of the number of rows produced by that join is a factor of 5 too small, and that can have a big effect on the join order, what other operations are done downstream from that join. So it's important to have stats to correct that type of problem. So how do you fix that? Now, if you happen to have an index on those columns, which is fairly typical, you get those stats automatically from the index, and those are the first key card stats. So within LEW, there's like a first key card, first 2 key card, first 3 key card, first 4 key card, and then the full key card. And so those ones will provide basically the number of distinct values in the combination of columns. But in situations where maybe you don't have an index on a combination of columns, this is where you would collect a column group stat. You wouldn't want to necessarily create an index just to get the statistic. So how do you collect a column group stat? It's just another option on the RUNSTATS command. Uses has this on columns clause and then and columns. So it specifies some additional columns. You put the all columns first to make sure you collect stats on all the other columns, and then you can say for this pair of columns, in this case policy number and policy revision, I want to get the number of distinct values in that combination. And then those just go into these additional system catalog tables. So there's actually two catalog tables that represent the column group stats. One has the Db2 will automatically assign an ID to that particular column group, and then that's where you'll find the cardinality. And then it's got a child table that's got the column names that are part of that column group. So you can take a look and see those in the catalogs if you want. So that's column group stats. And again, this is something that the stat advisor will recommend. So good thing to consider. Question over here.
If you take stats on column groups and you subsequently take another RUNSTATS, does that invalidate the column group stats?
So the question is if you had already collected column group stats,
Yeah.
and then you collect a different set of column group stats on different columns.
Just table stats.
Oh, just table stats.
Yeah.
So in general, the way stats collection works in LUW is that it's not cumulative. So it completely wipes out the existing stats and recollects just the stats with the options that you've specified, right? So you got to be careful that if you want to change your stats options, make sure it includes all the ones you had previously, right? Okay. Okay, so that's column group stats. Quickly, going to talk a little bit about detailed index stats. So a bit of background. So the detailed index stats, these stats represent the kind of the key stat with an index is represents how the data pages are organized with respect to the index. The index has some other stats, for about the index itself, the number of levels, the number of leaf pages. But the one that's really important for understanding I/O and costing it in the optimizer are these clustering stats. And there's two flavors of them. In the early days of Db2 back in version 2, it just had this cluster ratio stat, and it's just a value between 0 and 100. And it kind of represents the clustering of the data pages with respect to the index. So what that means is if you read all the data pages through the index, you start with the probe into the index, and you get the RID, and then you go find the data pages. If the data pages are not in the same organization as the index, you're going to be doing random I/O all over the place when you read through that index. So the cluster ratio basically said if it was 0, it's terrible clustering. It's going to be like every read for data page is going to be a separate I/O, or it's perfectly clustered, which means that if you go back, you're probably going to be reading from the same data page as you go through the index. And then we found that just that one value on its own didn't really, accurately reflect how the clustering works for data pages. So a couple of new stats were added. And again, this was like years and years ago, so it's just some kind of ancient history at this point. So we also have this cluster factor and page fetch pairs, and I'll next page I'll show you how the page fetch pairs work. We jump right to that. So the idea with the page fetch pairs is that it's just basically a set of 10 pairs of numbers, and one is a value that represents a buffer pool size, and the second value represents the number of fetches that would occur if your buffer pool size was only that small, or that particular size. How many I/Os would you need to do if you read all the data pages through the index? And so then the RUNSTATS will just basically build. It's basically a graph based on changing the size of the buffer pool. And the whole idea is that if the data pages are poorly clustered, as the buffer pool size shrinks, the number of I/Os is going to go up. And in the worst case, if it's a terribly clustered index, like what the yellow line here represents, the number of fetches could approach the number of rows in the table. And then if it's a perfectly clustered index, it doesn't matter what size the buffer pool is, because as it reads the data pages through the index, they're always still going to be in the buffer pool, because it's never going to have to revisit a page later on as it goes through the index. It's going to read through them sequentially. And so we collect these stats because the optimizer, as it's doing its costing, it does model how much buffer pool is available. And so if it thinks because of other operations going on in the query that the buffer pool is small, it will use this graph of page fetch pairs to get a better estimate of the amount of I/O that would have to occur if that index was used. So anyway, a bunch of history on that stat, but in case you're curious why we have kind of two flavors of clustering, it's because of this, we added this more detailed stat, I think back in version maybe 2. I always recommend collecting these detailed index stats, and they take more CPU time to collect. They can be quite expensive. So back in version 7, this sampled option was added for detailed stats, and now we've just made that the default as of 10.1. So if you just say run stats on table and collect detailed index stats, it'll just do the sampling automatically. It's a different kind of sampling than what I mentioned earlier, and so I won't get into the subtleties about how it's different. But it basically that type of sampling really doesn't affect the accuracy of the stats, and that's why we made it the default in 10.1. So just one less option that you have to worry about when you collect stats, and it's the default for auto run stats as well. So a bit of background on these detailed index stats. If you take anything out of that one section, if you're not interested in the ancient history, it's just run with that default run stats command I showed earlier in the presentation. That's really all you need to know about the detailed index stats. Next section, quickly, statistical profiles. So earlier I mentioned that you can there's a variety of options on the RUNSTATS command. Rather than you could record those in a script and keep them. keep them in a file or a job that gets run regularly. Another way to do that is you can actually register these in the catalogs with an option. I'll show on the next page, and these get stored in a column in syscat.tables called the stats profile. This is just basically the runstats command as you typed it. It gets stored in that column in syscat.tables, and so all the runstats options can be specified there. And so just go to the next page and show you how you use that. So the way you do that is there's a use profile and a set profile option. And there's also an unset profile option if you just wanted to get rid of it altogether. So just, rather than looking at the syntax diagram, let's just look at a couple of examples quickly. So, so the first run stats you see on this page, it's collecting distribution stats on certain columns, changing the number of frequent values. And then it has, the part in dark blue says set profile. So that's what registers it in the catalogs. And then the next time you actually want to collect stats on that table, rather than having to specify all those options, you can just say use profile, and it'll pick up whatever's in the catalog. The other big advantage with having the profile in the catalog is that auto run stats will also use those options. So, is there a question back here? Real-time stats will use some of the options. There's some it won't use the sampling options as is all the time. But yes, it'll use the column group stats. Yeah. So and then there's ways that there's also an update profile option as well. So if you've already got a stats profile registered and you want to change, you want to add some extra run stats options, you can just use this update profile option as well. And this example just goes. It gets a little bit tricky because the run stats options. You can combine them, and so once you've already got some options, and then you want to add some additional ones. The general idea is it kind of merges the new options with the previous options. So in this example, if I already had like stats and actually I think this was oh right, so so what this page is showing is kind of the combined effect of the run stats and update stats profile on the previous page. So I'm not going to, in the interest of time, I'm not going to walk through that one in great detail, but just pointing out that once you have the stats profile, you can actually update it with new options.
On the example you've given, you've not given any index run stats. Do you recommend splitting the two things out, tables and indexes?
Sorry, couldn't quite hear the question.
So on the examples you've given here, none of them say and sample detailed statistics to the index.
Oh, so your question is, how come I'm not showing the sample detail? Just to keep the example simple. Yeah. So yeah, I guess to reinforce that those are the defaults you should use, I put them in the example. But no, it was just simply to not clutter the slide up too much with the additional stuff. Okay, moving on to the second last section. So collecting stats with utilities. So these utilities have the ability to collect stats. So if you do load replace, if you have to, you're fully reloading the table, you can collect stats. Nice thing with the load is that you can also specify the stats profile. So that's another advantage with the stats profile, is that if you want to have the consistent stats options between doing a run stats and doing a load for that table, register the stats in the catalog, and then you can just specify use profile on the load as well. The redistribute command also collects stats and uses the stats profile. You can collect stats and create index. I'm going to show an example of that. And the advantage is just saves a second pass through the data to do the stats collection. The other key thing is that rather than waiting, like if you're using auto run stats, it's great. If you did these operations, auto run stats is eventually going to kick in and collect stats to reflect them. But it's just better for the system to have more timely stats that you use these options when you create the index. I'm sorry, question?
Drop a column on a large table, would you recommend?
Oh, the question is, if you drop a column on a large table, do you recommend running run stats? In that case, you don't have to, because the drop column is going to drop all the stats anyway from the.
Is there a reason why a classic reorg cannot collect statistics?
The question here is there a reason why the classic reorg can't collect statistics? And there is no reason, and that's a great question. And we would like to, very very good point, and we would like to extend reorg to collect stats as well, because a common thing is that you do the reorg and then you want to do a run stats to reflect the change in the data organization, right? And that unfortunately we should really be able to collect the stats during the reorg time, and it is something we want to get to at some point. So. Already talked about stat profiles and utility. So here's load, showing an example of saying use profile. Kind of already talked about the benefits, consistent run stats options, and just pointing out that for blue tables, column organized tables, if you don't say anything about the stats, it collects stats by default for the load. And so even if you don't have a stats profile registered, it will just use the same run stats options that auto run stats uses. So the distribution stats and indexes. The indexes that you might have in the column organized table if you had primary or unique keys. And then just quickly create index. So the sampled, unsampled, detailed stats options, you can put them on create index as well, and it's just faster to do that. So it saves a separate pass through the index pages later. Okay, finally on to the last section. Just want to say something about statistical views. So this is statistical views are probably the most sophisticated stat that LEW supports. I've talked about it at conferences in the past. You can spend like a whole session on that, so I'm going to kind of give a real quick overview of it here. But the whole idea is that you're basically creating a view, and then you do run stats on this view. And the stats are collected on the result set that is produced by that view. And so, why would that be kind of interesting to do? The idea is that if you create this view that represents certain patterns that your statements have, then the optimizer can use the stats from the view to improve its filtering cardinality estimates rather than just the stats on the individual columns. And the advantage with doing that on a view is that a view will allow the optimizer to see relationships that it would not otherwise be able to see by just looking at the individual stats on the columns and tables. And you don't have to change your queries to reference the view in order for those stats to get picked up. The optimizer will automatically match the statements to that view. So you don't have to change anything. You just have to put the view into effect. And so how would you do that? So what this example is showing here is kind of typical use case for stat views that one of kind of the original situations that motivated their introduction is a star schema. So what the stat view is doing is it's just creating it's a view over the fact table and 3 other dimension tables in the star. And it's basically just joining the fact table and pulling out all the columns from the dimension and projecting them out, and just joining on the primary key and foreign keys in the fact table. And so essentially what this view is doing is just like denormalizing the fact table and adding in all the dimension attributes and produces this big result set. And then you have to issue this extra statement. You have to switch that view on to support stats. The reason you have to do that is because there's some overhead in matching the SQL statements to the views, and we don't want to incur that overhead for every view in your system, so we only do that for these special ones. And then once you enable that for optimization, then you just do run stats on it, exactly like you would do for a table. So basically, all the stats options that would make sense for a view, the index options, of course, wouldn't apply because you really have indices on the view itself. But distribution stats, certainly, even column groups, you can collect column group stats on a view. And then the optimizer will use these stats to improve its estimates. And there's some good examples, developer works articles on how to do this and how it actually affects the optimizer. Some good examples in the Knowledge Center as well. And you see links to those in the presentation. And that's about all I'm going to be able to say on that particular topic, other than deciding what stat views to have, which is pretty complicated, probably even more complicated than column groups. But luckily, Data Server Manager also has a stat view advisor as well. And again, it works the same way as the stats advisor. You just give it a workload of queries, and it will figure out what stat views you should have. And it does fancier things like There's some other even more sophisticated stuff that you can do with staff views when they have expressions. And again, there's lots of good examples in the Knowledge Center and Developer Works articles. And that wraps it up. So that's just quick summary. But take a couple questions at the end, or we can call it a wrap, because I guess we got about 10 minutes before the closing session. So, one question here.
Question, I think. Statistical advisor, is it planned to implement this in the command line to add this?
The question is there any plan to implement that in the command line too? No, not at this point. I would say that if anything, where that advising capability might end up would be kind of in the engine itself, just automatically. Kind of the longer term vision for that. So, but I don't. In general, just a good point that you won't see DB2 Advis being extended for any more advising capabilities. What you have is that that's kind of the end of the line for it, and all new advising capability is being done in the tools. So, okay. No other questions? Be a wrap. Well, one more here, sir.
To have more than 2 concurrent auto-runstats running at the same time?
The question is can you
Can you have more than 2 concurrent runstats running?
No. So the question is can you have more than 2 concurrent
Is a fixed value?
for the auto run stats?
Yes.
Yes. The question is how many concurrent auto run stats? You can't have more than yeah. It's
Wouldn't it change in version 11?
no. Have not changed yet. And the only way you get 2 is if it's the kind of the regular auto run stats waking up, and then a second one that's being driven by real time stats. Okay. If there's any other questions, come on up after the presentation. Otherwise, I'm going to wrap it up and let people head out. Thanks very much.